So if we look at the actual code and the actual assignment that you're going to be working with here, I've got a few things written at the top. And basically, these are the rules for this assignment. Again, no global variables. So nothing should be dimmed up here at all. Anything that appears in any of the functions that you're working on must exist in that function. And that is to say, either it's going to be in the brackets here, indicating that the user is going to send me in values to fill in these variables, or it's something that I've dimmed right here that I can use throughout. Now, without getting into it too far, essentially what this first function does is it receives three numbers. Whatever those numbers are, it stores them as n1, n2, and n3. It dims this temp min value to be used throughout because I decided I wanted to be able to do that. And then it sort of works with those pieces of information to hopefully send back the smallest value to find the minimum. Again, nothing here or nothing in this function exists outside of the function. So we'll see that momentarily as well. Basic rules, again, no global variables. Do not touch anything or fix, as you would say, the code in the main button program in any way. And do not add anything to the main button program either. So sort of down below these lines here that says no typing beyond this point, this is all my work. And this is my work to test your work. So you don't need to see what's down there. You're allowed to peek, that's fine. But the idea again with a function is my function should work regardless of who's using it. If I send this code to somebody else and it's working properly, then their variable names or where their numbers are coming from or anything else doesn't matter. They send in the three numbers to find min, I send back the answer, and we're both happy. Now, if we take a peek at what this does, right now it says, and I'll show you this in a second, basically there's just a little menu-driven system, but the program that is using find min picks three random numbers, and then it prints them on the screen just so you can see what they are. And then this line calls find min. So this says make my variable called smallest equal to whatever number find min sends back. So whatever find min decides is the minimum value, it gets stored here as smallest. And so we're sending in A, B, and C, and then we're going to print the value that was sent back. So we send in A, B, and C. Find min stores whatever those numbers were as n1, n2, n3. So again, very important to recognize these are not the same names as what was being sent in, but that's okay. Essentially, the program says take these three numbers. They were called A, B, and C. The find min says no problem. I'm going to call this one n1, this one n2, this one n3. And then it makes use of them in here and sends back what it thinks is the answer. So if we just run this, pull this over here so you can actually see it. Oh, don't do that. Pull this over here so you can actually see it. This is the one called smallest value. So basically I click on it and I'm going to run smallest value. It tells me that the original values were 10, 2, and 4. And then it sends back the value that was returned from the function. The minimum was the value of 2. So you don't know necessarily what happened in the function, but you know that it sent back 2 as the minimum. So that sounds pretty good. Try it again here. Negative 11, negative 10, and 14, and it says minimum is negative 11. Beautiful. Negative 25, 13, and 16. Hopefully it says good. Minimum is negative 25. So it looks like the code is working just fine. Minus 23 is the smallest here. Beautiful, minus 23. Here we see 18, 15, minus 6. So obviously minus 6 is the lowest. Oh, wait a second. It looks like the code didn't return the correct answer in that case. So if we quit here and kind of go back in. So again, down here, the program is randomly picking three numbers and sending them in as A, B, and C. Or sorry, printing them out here as A, B, and C, and then sending them to the find min thing as A, B, and C. And then all it's doing is it's printing whatever find min sends back to it. So again, all of this code is completely independent of find min, other than the fact that we give it our three numbers. If these three numbers were found some other way, the user typed them in, or they were numbers pulled from a file perhaps, or it was me just saying, hey, these are my favorite numbers, can you use them? Find min would work the same way. It receives the three numbers, calls them n1, n2, and n3, and then tries to work with them in here. Now, if we look at what it's doing, it says basically compare n1 and n2, so the first two numbers. If n1 is bigger than n2, make temporary minimum n2. Otherwise, make temporary minimum n1. So the reason the code was working for the first few examples was the smallest number in the list happened to be one of the first two numbers. But you can sort of see here, I'm not actually dealing with n3 at all. And so your job will be to add in code here that takes what's already been done. It's already found the smallest of the first between the first two numbers and compares it to the third number, and then hopefully returns the proper temp min for all cases. Similarly then, if we look at the next example, calculate the hypotenuse. Once it runs, it says Pythagorean Theorem here, so I'm going to run that code. And it says type in the length of the first side. Well, I'm going to go with a 3 for the first side. I'm going to go for a 4 with the second side. And it says the hypotenuse of your triangle is 13,666. Obviously not quite right. So let's just look at what our function does here, or sort of how this code runs. So down here, basically, it's asking me to type in side 1, type in side 2, and then side 3 is the result of this calculate hype. Side A and side B are sent in, and then whatever the function sends back gets stored as side C and printed on the screen. So let's just see what calculate hype does. Oh, not too much. So basically, at this point, all calculate hype does is it receives the A and the B values, doesn't actually make use of them at all. It says make hype equal to 13,666 and then return hype. Similarly, I could say something like hype equals A plus B and have it return that instead. Now we know that's not the Pythagorean theorem. We know that's not going to do exactly what we intended it to do, but if we just try it, you can see that we're now getting the result of whatever code we've got in here being sent back. So your job in this case now is to write the code that will calculate correctly the hypotenuse given A and B that are being sent in. And then, of course, this is set up to already return the hypotenuse correctly. So as long as you can do the calculations in here correctly, the rest of it will take care of itself. Last kind of comments here, just sort of now that hopefully the idea is there, we can deal with more specific questions as they come up. Yahtzee attempts. This kind of explains what, if you haven't played Yahtzee, this explains what a Yahtzee is. Essentially, Yahtzee is 5 dice have been rolled and they all have the same value. So you have to write the code in here that will roll 5 different dice, similar to a problem you did in the do loops assignment, the insect eyes. And then essentially, we have to count the number of attempts it takes us to get to the point where we do have a Yahtzee. So essentially, we have to continue to do this getting 5 different dice values, and we have to loop until those 5 dice are all the same. So die 1 is equal to die 2, and die, oops, I guess I can't really do that without dimming some variables first, but we have the idea. I'm going to get 5 different die values if die 1 is equal to die 2, and die 2 is equal to die 3, and again, essentially this is a problem that you've already done. Each time through the loop, you'll need to count the fact that I made one more attempt, I made one more attempt, I made one more attempt, and then you're going to send back however many attempts it took to get the answer. Is even, again, a question you've probably done way back in the if statement stuff, and you're just now including it in the function instead and sending back true or false so that the rest of the code works with it. This one is create a function called Factorial. If you haven't done the Factorial, you can let me know. Some groups will have and some won't have. Maybe we can switch that out. And then Yahtzee Average. Basically in Yahtzee Average, what we need to do is we need to run the code 100 times. That sounds like a for loop to me. We need to call from within this one, this code up here, have it run and send back the roll count. And then we need to average the roll counts for the 100 attempts. So basically, for loop will do the 100 attempts. In there, we need to call the other thing each time, and then we'll get back the roll count, we'll add them up, we'll divide by 100, and that will be the answer to, on average, how many attempts does it take for us to get a Yahtzee. So I don't want to spend too much time. The video is much longer than I intended it to be, but hopefully that gets you comfortable getting started, and then we can deal with individual questions as they come up. The subsection, the following assignment, is very, very similar, except again, functions send back an answer, subs do not send back an answer. So you'll be working the same way, building up the subs with the understanding that they're not sending back something, they're just completing a task, and then at that point, the rest of the code should handle the task that you've completed.